NCERT Class 7 Science Chapter Electric Current and its Effects. Symbols of electric components. It is convenient to represent electric components by symbols. Using these, an electric current can be represented by a circuit diagram. Battery. The positive terminal of one cell is connected to the negative terminal of the next cell. Such a combination of two or more cells is called a battery. Switch. When the switch is in the on position, the current from the positive terminal of the battery to the negative terminal is complete. The circuit is then said to be closed and the current flows throughout the circuit instantly. When the switch is in the off position, the circuit is incomplete. It is said to be open. No current flows through any part of the circuit. Bulb. The bulb glows only when the switch is in the on position and the circuit is closed. In the bulb, there is a thin wire called the filament, which glows when an electric current passes through it. When the bulb gets fused, its filament is broken. If the filament of the bulb is broken, the circuit will not work. Heating effect of electric current. The wire gets hot when an electric current passes through it. This is the heating effect of electric current. Electric room heater or an electric heater used for cooking use this technology for its purpose. All these contain a coil of wire. This coil of wire is called an element. When these appliances are switched on after connecting to the electric supply, their elements become red hot and give out heat. The amount of heat produced in a wire depends on its material, length and thickness. Thus, for different requirements, the wires of different materials and different lengths and thickness are used. The wires used for making electric circuit do not normally become hot. On the other hand, the element of some electric appliances become so hot that they are easily visible. The filament of an electric bulb gets heated to such a high temperature that it starts glowing. If a large current passes through a wire, the wire may become so hot that it may even melt and break. Wires made from some special material melt quickly and break when large electric currents are passed through them. These wires are used for making electric fuses. In all buildings, fuses are inserted in all electric circuits. There is a maximum limit on the current which can safely flow through a circuit. If by accident the current exceeded this safe limit, the wire may become overheated and may cause fire. If a proper fuse is there in the circuit, it will blow off and break the circuit. A fuse is thus a safety device which prevents damage to electric circuit and possible fires. A fuse is a safety device which prevents damage to electric circuit and possible fires. These days, miniature circuit breakers (MCBs) are increasingly being used in place of fuse. These are switches which automatically turn off when current in a circuit exceeds the safe limit. Incandescent electric bulbs are often used for lighting, but they also give heat. It means that a part of electricity consumed is used in producing heat. This is not desirable as a result in the wastage of electricity. The fluorescent tube lights or combat fluorescent lamp CFLs are better electricity efficient lighting sources. Nowadays, the use of light emitting diode LED bulbs is increasing. For producing a given intensity of light, LED bulbs consume less electricity as compared to incandescent bulbs or fluorescent tubes or CFLs. Thus, LED bulbs are much electricity efficient and therefore being preferred. Magnetic effect of electric current. When an electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of the electric current. Hans Christian Ørsted was the first scientist who discovered the magnetic effect of electric current. Electromagnet. When the electric current is switched off, the coil generally loses its magnetism. Such coils are called electromagnets. The electromagnets can be made very strong and can lift very heavy loads. Electric bell. An electric bell has an electromagnet in it. It consists of a coil of wire wound on an iron piece. The coil acts as an electromagnet. An iron strip with an hammer at one end is kept close to the electromagnet. There is a constant screw near the iron strip. When the iron strip is in contact with the screw, the current flows through the coil, which becomes an electromagnet. It then pulls the iron strip. In the process, the hammer at the end of the strip strikes the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip, it also breaks the circuit. The current through the coil stops flowing. The coil is no longer an electromagnet. It is no longer attracts the iron strip. The iron strip comes back to its original position and touches the contact screw again. This completes the circuit. The current flows in the coil and the hammer strikes the gong again. This process is repeated in quiet succession. The hammer strikes the gong every time the circuit is complete. This is how the bell rings.